in Seoul today, and Korea is absolutely the king of food preservation country in the world. Why is that? Because of their most famous product, kimchi. But there are so many different kinds of kimchis, actually. There are hundreds of different kinds. So here we have three, and this one is called kimchi. That's made with regular cabbage. And then this is called gakdugi, and gakdugi is made with Korean radishes. And this is kimchi, and this is from the little leaves that grow out from these little micro radishes. There's lots and lots of different kinds of kimchis. Now, why is this important, and what is kimchi, and why is it so important for your health? Well, first of all, it is preserved by fermentation of lactic acid bacteria. So lactic acid bacteria take this and they make a bunch of acid in there to raise the pH quickly so they outcompete other microorganisms that could be potentially pathogenic, make you sick. But they've got this worked out really well so that these lactic acid bacteria start to grow really fast, lower the pH, killing everything else, perfectly safe and ridiculously healthy. Why is it ridiculously healthy? Well, one of the reasons is the vegetables that they chose to preserve. They are coniferous vegetables, things like cabbage, radish, mustard greens. And all those have a two-pronged defense system. And back then, before they started breeding them to make them a little bit more palatable, wow, were they bitter. So the Koreans probably tasted that a long, long time ago, thousands of years ago, and said, this is some of the worst crap I've ever eaten. I can't even choke this stuff down. And then some early genius figured out how to, through fermentation, make these not only more palatable and enjoyable, but extraordinarily healthy. So let's take a quick look here at the starting material. This is radish. Okay, now a lot of radishes still to this day, even though they've been selectively bred, don't taste that good. I made this myself, and this is from this particular radish that's been in the refrigerator for a long, long, long time. When this was raw, this thing, when I bite into it, it has those chemical defenses in there. Wow, is that bitter. I don't want to eat that at all. And it's really sharp and pungent. What is that? That's defense system number one of coniferous vegetables. Glucosinolates. So coniferous vegetables, they don't want to be eaten because these are storage systems for the vegetables for nutrients and things like radish. It's got a lot of stuff in there, and it's going to grow into a new plant the next year. It doesn't want to be eaten. Well, to ward off people, wow, that bitterness just keeps going. Yikes! So, to ward off people and animals, the first primary mode of defense is glucosinolates. So I'll draw this molecule, and this one. All right, this is the glucosinolate. They're really bitter, and they're not pleasant at all. And this is why this drives away animals and humans from eating this storage vessel for the plants. So it keeps grazing from happening. Well, what about microbial things, viruses, bacteria, things like that, that can't taste that because they don't have the olfactory nerves, they don't have the sensory nerves on their tongue or in their mouth or in their nose to taste things because they don't have tongues, mouths, and noses. They need to have the secondary defense system. So these glucosinolates are inside of a little package in the cell. So here's a cell, and inside the little package here, you've got the glucosinolates. They're just sitting here ready, so when people bite into them, oh, the bitterness kicks in, you stop. But for bacteria and viruses, what happens is you've got another little package in here, and in here is an enzyme called myrosinase. So as soon as bacteria or viruses or funguses start to chew into the cell here, they're going to start chewing this. They're going to break this open. The myrosinase and the glucosinolates are going to come together. This myrosinase is going to chop right here, and it's going to make a new molecule which has antimicrobial properties. It's going to kill those microbes, and that is called isothiocyanates, thiocyanates, and all kinds of other ones. So what is that one? Let's see, can I do it? Yeah, I can just do it right here. It's a pretty easy one. All right. Okay, R just stands for pretty much anything. It can be carbons, nitrogens, oxygens, hydrogens. There can be a lot of stuff in there. So here is an isothiocyanate. So this nitrogen, carbon, sulfur, this R just stands for a whole bunch of different ones because there are so many different kinds of them. So this molecule and a lot of other related ones, and each different type of kimchi is going to have each different type of molecule. And these are not only antimicrobial, they're also anti-cancer, and a lot of molecules in there are anti-mutagenic, so they help fix your DNA if it's been mutated. They are antioxidants, so it keeps any of the oxidative damage from happening. And there's another benefit of kimchi. Not only do you get these molecules, but you also get all of the probiotics. So those good beneficial bacteria that you hear about in the news all the time, you know, the link between your gut and your brain and your gut and your heart and your gut and everywhere else, the probiotics inside the kimchi are going to give you that good bacteria that you want in your intestines. They're going to make things like butyric acid, those small little molecules that also are good for signaling and good for health and such. So you get these molecules, which are good, then you get the probiotics, and that's what makes kimchi so amazingly healthy. Now, why do I have 3 kimchis here? Well, the reason is each one has slightly different molecules. So you want to eat a wide variety of them to get the maximum health benefits. And also because maybe you get tired of one and you want to have a little bit of a kind of change it up, a little bit of a different flavor profile. So let's taste these. Oh, by the way, fresh kimchis, if it's just been made, it's still going to be good, but it's not going to have the maximum benefits because during the fermentation, remember, during this fermentation, you're going to get the same activity is going to be happening. The myrosinase is going to go in there and it's going to cut the glucosinolates here to get rid of that bitter flavor, or the enzymes in the bacteria will do that. So you'll notice when people make kimchis, a lot of times they'll need those vegetables. That's breaking those cells and making this reaction happen. And then as you get the fermentation done by the bacteria, that's doing additional cutting of this bond here to get rid of that awful bitter flavor. So let's do this again one time now. Same piece of radish. I don't know why I'm eating that again. It's punishing. I don't like it at all. Now, let's take a look at this. This is about maybe 6-7 days old. Bitterness is all gone. You get a nice, pleasant sourness, a little bit of natural sweetness, a little bit of savoriness as well, because there's a little bit of protein in here. And during fermentation, you're going to cut off some of the amino acids, which will make it taste a little savory and a little bit sweet. That's nice. That's way better than this, and it's much, much healthier. Oh, by the way, if you cook kimchi and you make a stew out of it or something, you're still going to get these molecules, which are very good for you, but of course the probiotics will be all dead because you've cooked it and you've killed them. It's still good for you, but you're not going to get the maximum benefits. Now, here is the cabbage kimchi. And cabbage sometimes also can be fairly bitter. Again, bitterness is all gone. Quite enjoyable to eat that. Not only does it taste great, but I know it's great for me. So, the yormu kimchi, again, a different flavor profile. All of them are excellent. I love them all. But what is the king of the fermented vegetables in Korea? It's kimchi. Why is that? Because that is the most awful bitter vegetable that they make kimchi out of in Korea. It is so punishingly bitter to begin with. But because it has so many glucosinolates, as you do the fermentation, you're going to get more beneficial molecules out of it. So that's why kimchi is extraordinarily healthy. I don't have any here. Why? Because I ate it all. That's why, because it's so darn good. So what's the takeaway for this? Eat kimchi every day. Eat different types of kimchi every day. You will feel so much healthier. You'll have so much better balance of gut nutrition, and everything's interconnected there. And you will have anti-cancer molecules. You'll have antimicrobial molecules. You'll get isothiocyanates, thiocyanates, and a host of other things that we don't have any space to write here. So do yourself a favor, eat kimchi, be healthy. We have to give special thanks to the Korean researchers who have done tireless efforts to elucidate why kimchi is so good. We have to say a special thanks to the people thousands of years ago who developed this wonderful process, and a special thanks to the plants for providing the molecules that make all of this possible.